All right, everybody. So today, as part of our review, we're going to go over some SBAC style questions. The first ones that we're going to do here, of course, have to do with quadratics. That's why we chose these on purpose. So here we go. It says solve equations and inequalities. Again, this is the quadratics SBAC basically style questions. There will be some similar to it on the test that you're going to be taking this week. So it's a good review for the test, and you get to see what the SBAC looks like. All right, so it says, which equation has no real solution? Well, keep in mind, when you're looking at your word wall, the only time that we've heard them say maybe no real solution, well, think about it. If it's not real, well, then it has to be imaginary. And all they want to know is, well, which one has no real solution? And according to our word wall, if you are not going to have a solution, well, that's why we have this little part here. The discriminant, notice that gave us that hint. In the discriminant, they tell us this: if it's a positive result, we have two real solutions, zero result, one real solution, and if you get a negative, then we have two imaginary. So that's what we're looking for, right? We said no real, so we're looking for imaginary. So then here we go. We're going to set up the discriminant here. Let's start off with A to test that one out. There's my A value, B value, C value, of course, as always. So B squared minus 4AC. Yes, we say the letters. We didn't write them in yet. And so my B value is a 2. My A value is a 1. My C value is also a 1. And then, of course, we can let Desmos handle a lot of this work for us, or we just do it ourselves, of course. So let's see. Let's just do it ourselves here. 2 squared is 4. 1 times 1 is just 1. Remember, we're trying to multiply all of these here. Still a negative in this case, so negative 4. And 4 minus 4 is 0. Well, remember, when you get a 0, that's one real solution. So that's not what we want. We're looking for no real solution. All right, so it can't be A. We'll cross that out. We try the next one. So we go to B here. B, there's my A, B, C. So here we go. B squared minus 4AC. My B value is, of course, a 4 for this one. My A value is a 1. My C value is a 2. So for this problem, we get 16 minus 8. And 16 minus 8 is an 8. But remember, the number really doesn't matter. It's the fact that it's positive. And because it's positive, it means there are two real solutions. So again, that's not what we're looking for here. Sorry, I just realized that most of it was off screen. So again, when we set it up, we worked it out. The positive number tells me we have two real. We're looking for no real, so this one's out as well. All right, we keep it going. So now we're going to try C. So we've already tried A, B. So here we go. B squared minus 4AC. All right. My B value, of course, for this one is 5. My A value is 1. My C value is 7. So now let's test this one out. We end up with 25 here. And again, you could just let Desmos do all of this. 4 times 7 is 28. And I get an answer of negative 3. And there it is, everybody. We've been waiting and looking for this negative, because when you get a negative, it means you have two imaginary numbers or two imaginary solutions. And if you have two imaginary, well, then that also means you have no real solutions. I'm just going to write that for short there. And that's exactly what we're looking for. We're looking for the no real solution, so then my answer is officially C. So again, I know that in our notes we call it imaginary numbers. We say two imaginary roots, but it could also mean no real solution. But again, it's the quadratic, not the quadratic, but the discriminant that gives us this result. All right, moving on to number 2. In number 2, we did something very similar to this in our review. So again, that's why we use our review to help us out. So it says, solve the following equation for S. Okay, so there's my equation. Enter one solution in the first box. If there are two solutions, well, then we'll enter it in the second box. So the SBAC sometimes wants you to split the answers, but notice it says if there's two solutions, then you would use the second box. So we don't have to, not necessary. All right, so here we go. I'm going to copy the question down. 4s squared minus 100. The power of 2 tells me that this is a quadratic. And remember, to solve a quadratic, we can use factoring, right? But it says this only really works if you have two x's. I only see one letter, so if I have two letters, I would use factoring. So this one doesn't quite work that way. Solving by square roots, and remember when you're solving by square roots, you do have to reduce them. But that's only when you have one x or one letter only. And yeah, this one has exactly one letter only. So according to the word wall, it says, get this all by itself. So again, we did have a practice one like this already on our review. So if I want to get this by itself, the first thing we get rid of is adding and subtracting. So I have to get rid of the 100. So we're going to add it over to the other side. Okay, that's gone. 4s squared is equal to 100. Again, look, this is still not by itself. That's why I like highlighting. It tells me that if I'm looking at what I have in yellow, that still needs to go away. That 4 should not be there. And again, that's where highlighting and color coding helps. So I'm going to divide by 4, because that's how we get rid of the 4 next to the s squared. All right, I don't want to jump into this problem, so I'm just going to scoot it over this way. So then 4 divided by 4 cancels. I'm left with s squared is equal to, and then 100 divided by 4 is just 25. All right, and then how now you see it's finally by itself. So when the s squared is finally by itself, according to the word wall, see, now we bring in the square root. But when we're looking at that part of the word wall, it says, okay, get the s squared by itself. I'm going to take the square root of both sides, but look, there's going to be two answers. And this is the one thing you have to be careful on the test. You have to make sure you put that plus or minus. So s is equal to plus or minus. See, now I can take the square root. And this is why we've been working on our powers of 2. The square root of 25 is a simple 5, and I'm hoping that you're not having to check those on a calculator anymore because we're asking you to memorize these. Now, that's why we have two boxes here. We're going to say s is equal to 5 and s is equal to negative 5. And honestly, in the SBAC, usually they just want the numbers. They usually don't even want the letters written out. Okay, so again, very much like a test question you're going to get. Well, here's another test question possibility for you. Notice it does say hint, use the discriminant. It says which equation has no real solution. So this is exactly what we did above. So it's the exact same type of question. So we're going to do what we did earlier. B squared minus 4ac. Here is my A, my B, and my C. So it's the same question. All we're doing is just testing it out. This is a negative 5. We're plugging in. We're going to see if we have no real, then I want to see a negative result. The A is 1. The C is negative 6. So this becomes 25. This becomes positive 24. So yeah, this isn't going to work because it's a positive 49. And again, positive means you have two real. Well, I'm looking for no real. I'm looking for imaginary. So that one didn't work for us. So we're going to try the next one. So A is out. I'm going to try B now. Again, there's an invisible 1 there. Some B squared minus 4AC. We say the formula. We just don't write the letters yet. All right, let's plug in. My B value is 3. My A value is 1. And my C value is 4. So we work it out, and again, just let Desmos do this entire thing for you. Practice, type it in carefully. That is 9 minus 16. And of course, 9 minus 16 is going to result in a negative 7. And there it is. I don't need to keep going because when I have a negative result in my discriminant, it means I have two imaginary. And if you have two imaginary, well then clearly none of those are real. They are imaginary. And that's what we're looking for. So B is our answer for this problem. So again, a lot of things that you're going to be seeing on the test this week. So it's a good review, and you get to see what the SBAC looks like. All right, let's flip the page there. Again, you're really just double checking your answers and fixing the ones that you got wrong as you go. All right, so here we go again. Look at what it says. Solve the following equation for Z. I do notice that Z has a power of 2, but when I look at it carefully again, there's only one Z. There isn't two of them. Well, then this is what we just showed you earlier. So I'm going to take this equation, negative 2 z squared is equal to negative 72. And remember, my goal is to get z squared by itself. Well, if I want to get z squared by itself, notice there's only one number I need to get rid of, and only division can get rid of a number that's next to a letter. That dates back to our Algebra 1 days. So we end up with z squared is equal to, and now negative divided by negative is a positive. 72 divided by 2 is 36. Now we're ready. See, the z squared is officially by itself. I am going to take my square root of both sides. And, let's write our answer over here. Z is equal to, but don't forget, this is where people make mistakes. You have a z squared, which is basically saying you have two answers. That's why there's a power of 2. So don't forget that plus or minus on the day of the test. And if my plus or minus, well, the square root of 36 is 6, so there you go, 6 and negative 6. That's how you would answer it on the SBAC, where they want you to write the answers in there. Again, they don't even want you to write z. Okay, moving right along. Now, when I look at 5, it says, what are the solutions to the given equation? And yes, I see a quadratic, but I see an x here and an x there. So I clearly can't do what I did up here. You can't say, I'm going to get x squared by itself. No, we can't do that. But this is where your answers can always guide you. So please use your answers as a guide. See, when I look at my answers, this looks very familiar to me. In fact, if I look at my word wall, see, it looks just like this setup. That's how we know this is a question where I should use the quadratic formula. So use your answers on the test to guide you sometimes. This is a great example of that. So then I'm going to go with the quadratic formula. Remember, we did attack it a little bit differently when we did this in class. We said, you know what, let's break it up into parts. So first of all, there's my A, my B, my C. And what we did in class was we actually talked about the discriminant first. Because notice, some of these have I in them, some of them don't. So the discriminant is going to help me reduce the number of choices. So it says b squared minus 4ac. Again, it's in your form, it's in your word wall there. All right, b squared minus 4ac. We're going to plug in our numbers. So b squared is 5 squared. The a is a 1. The c is a 25. All right. Now, if I work it out again, please just let Desmos handle that entire part for you there, because this becomes 25 minus 100, so it's negative 75. And look, this is why the discriminant is so important. We now know that I have 2 imaginary. And if you have 2 imaginary, then the letter I better show up in your answers. So you see, when I'm looking at my answer choices, I see an I right there, no I, and I see an I right here too, which means, see, look at that. The discriminant already allowed me to cancel 2 answers out that make no sense. So again, this is why we do the discriminant, especially for a multiple choice test. It already helped me out there. But now I can finish the problem. I'm going to do the quadratic formula. And now the quadratic formula is a little bit shorter. It says x equals negative b plus or minus the discriminant, which we already did, so we don't have to do it again, right? It's my discriminant that you just found right there, all over 2a. So here it is. X is equal to negative parentheses, all over 2a. All right, so my b value we said was 5. My a value was a 1. And my discriminant, well, don't forget, you already found it. It was negative 75. And so in my next step, all I have to do is go negative 5, right? Negative times a positive, plus or minus the 2 at the bottom. And notice everything looks the same on both here. In both of my choices, they have the negative 5 and the 2 at the bottom. So that's not the issue. It's the 75. None of them say 75. That means I need to break it up. Now, first of all, it has a negative inside, so we know I has to be there. All right, but we have to talk about that 75 right here. So let's see. 75. That's why we need to know our powers of 2. And when we're wondering, okay, well, what multiplies to give me a 75? 25 times 3. And the square root of 25 is 5, which means the radical 3 stays inside. So that's what goes up here. There's the 5, and there's the radical 3 that stays inside. So because of that, clearly this 25 made no sense, but this is the one that worked for us perfectly. All right. Again, yeah, the quadratic formula is going to take a little bit longer, but you already saw some questions on the test that aren't going to take long at all. So you're going to have plenty of time for it all. All right, let's look at number 6, last one on this page. Now they do give us a hint. They said, hint, take out the GCF first. Solve the following equation for x. Enter one solution in the first box, enter a second if necessary. All right, but we do have a quadratic. All right, so here's my quadratic. Now, it does have two x's. Now, I have no idea how they want me to attack it. I could do quadratic formula because I could do that for everything. But look at the hint. We should always be checking for factoring. That's what I'm going to do here. I'm going to factor. And they said, well, figure out the GCF first. All right, well, look. Let me write this equation down again. 3x squared minus 9x minus 30 is equal to 0. If I'm thinking about a GCF, well, think about it. The 3 is the smallest number. 9 can be divided by 3. 30 can be divided by 3. Well, my GCF then is officially a 3. And if my GCF is a 3, don't forget, you got to write it out. And in parentheses, look, you're still going to have a minus. You're still going to have a minus right there. But technically, I'm going to divide everybody by 3. So 3 divided by 3 is gone. There's my x squared. 9 divided by 3 is 3 with an x. 30 divided by 3 is 10. Remember, that is always the first step in factoring. The next step is now, again, the 3 is there forever, is to break it up into two parentheses. That's the whole idea of factoring. Breaking it into two factors here, so it says x squared. The easy part is to go x and x. Now, the number I'm going to look at is the 10. So here's the 10. 10 times 1, I'm going to list all the factors. 5 times 2, and that's pretty much it. But remember, factoring is all about a goal. And the goal in this factoring problem is I'm going to subtract, and when I subtract, I'm going to get a negative 3 as a result. Well, think about it. This is just an x. 5 and 2, they're the ones that if you subtract them, it does give me a 3. So I'm going to definitely write those in, 5 and 2. But now the question is, well, who's the negative, right? Well, I want to end up with a negative 3. Well, then that means the bigger number should be the negative. So here comes my negative and my negative. Now remember, we are not done. We're done factoring, which is good. But now I actually need to finish solving the problem. And what they want us to do, right, if we're trying to solve for x, well, I have two of them. I make each factor that has an x equal to 0. Remember, you can divide by 3 and get rid of that 3 if you want to, but again, we really just care about the factors that have a variable. So here, we're going to add a 5, so x equals 5. Here, we're going to add the number 2, well, then x equals 2. Wait a minute. This is supposed to be a positive 2. We said only the 5 was negative. All right, so good thing is I haven't written it. So there's my plus 2. So how do I get rid of a plus 2? We subtract a 2. And so these are my two answers using factoring. So we're just going to write 5 and negative 2 in our boxes. All right, so that brings us to our very last page here, the last few problems of this review. Again, we're using it as a review and as a way of looking at the SBAC questions or how they're phrased. All right, solve the following equation for B. All right, once again, this is something we've already done. All I have to do is get B by itself, and notice, there isn't an extra B, so I don't need to factor. If they want me to solve, your ultimate goal is get the letter by itself. So then, let me copy it here. We have more room here. 12b squared minus 27 is equal to 0. And if my goal is to get b squared by itself, then I'm going to use everything my Algebra 1 teachers taught me, which is get rid of addition and subtraction first. So there's the 27 being added to both sides. 12b squared is equal to 27. Again, my algebra teacher said if they're right next to each other, then divide. Only division can get rid of that multiplication by 12. So that's gone, leaving you with b squared is equal to, now when you look at this, you might say, yeah, none of that really works. 27 and 12 can't be divided. But if you think about it, they can be reduced. So we could reduce our numbers. In fact, they can both be reduced by, and decimals can do the reducing for you. We can reduce them by 3. And if I do that, 27 divided by 3 is 9. 12 divided by 3 is 4. See, we always want to reduce our fractions. Now I'm ready. How do I get rid of a power of 2? That's when the square root comes in. But because I'm taking a square root, you have to remember that the very first thing I have to do is say plus or minus. Now, you might say, okay, but how do I do fractions? Well, remember, you got to do the top first. And that is a perfect square. We know that. That's on our list. So the square root of 9 is 3. Well, the 3 comes out of the square root. And now I'm just going to do the bottom separate, so I do need a fraction. And then the square root of 4 is also a perfect square, so it's just a 2. And when they said, well, enter your answers, well, this is 3 over 2. And then this one is negative 3 over 2. Now, moving right along, let's see what the next one has in store for us here. Number 8, solve. Okay, I'm going to solve for W. It only has one W, though. Then it's exactly what we just did. Wow, they really want to make sure you remember that plus or minus here. All right, well, that's good. That means it's easy enough. So again, my goal is get W by itself. So like my Algebra 1 teacher said, get rid of adding and subtracting first. So we're going to get rid of that 4. And then we have 25 W squared is equal to 4. Again, I can't bring in the square root too early. I have to get rid of the 25 that's next to it. The letter, the variable, needs to be completely by itself. So W squared is equal to, now, if you're wondering, well, can I reduce these? No, and I wouldn't want to anyways, because remember, we already know what the next step has to be. To get rid of a power of 2, I have to take a square root. So one of the reasons why I wouldn't even want to reduce it, right, here's my W, and again, plus or minus, you can't forget that. Here's the reason I didn't want to reduce it. The square root of 4 is a nice little 2, so why would I want to change that? The square root of 25 is 5, so you see they're both outside of the square root, or out of the radical. So that's why I didn't even want to. I wouldn't want to reduce them, but it was impossible anyways to reduce. And then those are my 2 answers. So again, they're really hitting you with this idea of don't forget the plus or minus when you use this technique. So I really hope you don't on the day of the test. All right, number 9. Number 9 says, solve the following equation for P. And look, all right, again, they really like to throw this question at you. And so chances are, right, if we see it this much, that means we've seen it a lot on the SBAC maybe for students. So maybe this is a question most of you will get because you're in Algebra 2. Well then, look, divide by 3, you are just solving. In the SBAC, you got to keep things simple. If it says solve, just get the letter by itself, right? If that's all you can remember, well, at least do that. So then P squared is equal to 25 when you divide it. And you see, now it's ready. Take that square root. And of course, P is equal to, and if you already say, oh, 5, then you did it too soon. You have to have 2 answers because of our power of 2. And the square root of 25, now you can answer it and say 5. So our 2 results are 5 and negative 5. So again, they're really making sure that we are really making sure you don't forget that plus or minus with this type of problem. All right, last one to check or fix if you needed to. Number 10. The graph of a function, f of x is equal to x squared plus dx plus 9, has only one x-intercept. Excuse me. Select a value for d that satisfies the condition. Okay, look, they're basically saying D equals, D equals, D equals. They just want to know, all right, what number do I put in there so that my graph has only one x-intercept? So I've seen people plug in numbers, plug in the 6 or in the 9 and the 10, but remember, you can't do much with it unless you're going to factor, unless you're going to use quadratic formula. That's too much work. Look, one x-intercept. Another way of saying that is one real root. And if it says one real root, this is discriminant talk. And your discriminant, just to have one answer, look, see, two real solutions. I know it's super small there, but it says two real solutions, one real solution. Well, that's exactly what they said. One x-intercept, one x-intercept. One real solution means your discriminant, b squared minus 4ac, has to equal 0. So my discriminant has to equal 0 according to them. All right, well, that's what I'm going to use. I'm going to use the discriminant, b squared minus 4ac, and I have to make it equal to 0. Well, look, there's your a. Yes, I know there's a letter D, but that's technically where the B goes. And then there's your C. And just like any other formula, whatever they give you, you plug it in. You don't think twice about it. So I'm going to plug in like I always do. And I'm going to plug in what they gave me, as weird as it looks. See, it says, give me the B. Well, the B is the letter D. Then there's an A. Well, the A is a 1. And the C is a 9. So there's the 9. And now I'm going to work out what I can. So it says d squared. Okay, that's easy. D squared. 4 times 9, so it's minus 36 is equal to 0. And look at that. Here we go again. It's one of those problems that we just saw earlier where all I have to do is solve. So then, just like my Algebra 1 teacher said, get rid of adding and subtracting first. So I'm going to add a 36. D squared is equal to 36. And just like before, I give it a power 2. Now remember, technically, there are two possible answers. D is equal to plus or minus. And now the square root of 36 is 6. So I do have two choices. But out of the ones they gave me, clearly, this is the only one that works for the letter D. So it was yet another one of those where we had to just solve using square roots. But again, the SBAC is all about making connections. One x-intercept means one root. It was discriminant talk. That's what it was. And it had to equal 0 based on our word wall. All right, with that said, everybody, you do have another assignment that you need to work on your homework, but you have plenty of time to do it. So try to get it done in class so you can double check your answers. And then be ready. Have that Chromebook charged and ready to go the next time I see you for the test. Have a wonderful day, everybody.